Hey, my fellow math enthusiasts! How are your multiplication and division skills coming along? I hope you're practicing every day. Since you've covered the basics of multiplication and division, as well as how to calculate with multi-digit numbers, it's time to learn some tips and tricks to help you multiply and divide quicker. Let's dive right in with tip number 1. Do you remember when a number is multiplied by 10, you just need to add a 0 behind that number? Like 3 times 10 equals 30. The same thing applies to 100, 1,000, 10,000, and so on. 100 has 2 zeros, so you add 2 zeros behind the other factor to get your answer. You'll add 3 zeros when multiplying by 1,000, and 4 zeros when multiplying by 10,000. Pretty easy, huh? You just need to count the zeros carefully, then put it behind the number, and that's your answer. Here's an advanced version of that tip. Can you multiply 2,000 by 40? Sure, we could put this in columnar format, but let's look at this in a different way. 2,000 has 3 zeros at the end, so that means that it's the product of 2 times 1,000. And 40 is straight up 4 times 10. Using the commutative property, we can move these factors in the multiplication without worrying about the results. Now we have 2 times 4 times 1,000 times 10. And we can merge 1,000 times 10 to make 10,000 because multiplying a number by 10,000 is adding 4 zeros to the end of that number. We just need to figure out what the product of 2 times 4 is, then add 4 zeros later. 2 times 4 equals 8. With 4 zeros, it's 80,000. So what have we learned? When multiplying with multi-digit numbers, and these numbers have zeros at the end, we can put those zeros to the side, multiply with what's left, then add all those zeros to the result. If you compare multiplying 2,000 by 40 with multiplying 2 by 4, it looks significantly easier, doesn't it? All right, tip number 2 coming at you. Normally, we calculate multi-digit multiplication by using our old friend, the columnar format. But if you find it hard to keep track of the steps and are afraid of making any mistakes, then maybe the grid method is for you. Let's take a look at this multiplication. 361 times 5. In multi-digit multiplication, we learn to take the bottom number and multiply it with each digit of the top number. In other words, we're multiplying by the ones, the tens, the hundreds, and so on. This means we're not just multiplying 5 by 1, 6, and 3. 5 is actually multiplying by 1, 60, and 300. Then when we add all the answers together, we get our final product. We're going to start by drawing a grid or a table. 5 will go in the first column, 300, 60, and 1 in the first row. Next, we'll multiply 5 by each of these numbers, put the product in the cell where they meet. Look at that! It works the same way as the multiplication table. Okay, let's start with 500 times 300. Remember our first tip? We take the zeros away, multiply 5 by 3 to get 15, then put the zeros back to get 1,500. We'll do the same thing with 5 times 60 to get 300. And 5 times 1 equals 1. Finally, we can add all these numbers together to get our answer. 1,500 plus 300 plus 5 equals 1,805. With this method, you won't miss any small multiplication steps, because you have all the numbers laid out nicely in a grid. Once you fill out all the cells in the middle, you'll know that you have multiplied with every digit, and you can start adding them together to get the final answer. Okay, are you ready for tip number 3? We have certain numbers that seem trickier when multiplying, but turns out there's a faster way. When you're multiplying a big number by 9, you actually don't need to remember the multiples of 9. You can multiply by 10, then subtract that number from the result. Why? Because when multiplying a number by 9, it's repeating itself 9 times. And multiplying by 10 is repeating itself 10 times. So you just need to remove that number once from the multiplication with 10 to get the result when multiplying by 9. If you need to multiply a 2-digit number by 11, here's how. You copy the digit from the ones place and put it in the ones place of the answer. Then add 2 digits together and put the sum in the tens place. Finally, you copy the other digit and put it in the hundreds place. Now, what if the sum of the 2 digits is 10 or higher? Then we'll use the regrouping method to carry 1 to the hundreds place and add that into the other digit in the hundreds place. If we calculate it in a columnar format, we can explain this tip. Do you see that these two digits reappear in the multiplication step and they meet each other in the middle? That's why we can copy them down and put their sum in the middle of the answer. Now, if you're multiplying bigger numbers by 11, we can use the same trick when multiplying with 9. You can multiply that number by 10, then add the answer with that number. So far, we've learned some quick multiplication tips. So how about we get into some division? The fourth tip is for when you're dividing with even numbers. Let's say 126 divided by 14. Just with a quick look, we know that this division can't be broken down into smaller division steps because we have to use all the digits of the dividend to make a number bigger than the divisor. That makes this problem one big and hard division. Here's how we can simplify this problem. Why don't we divide both the dividend and the divisor by 2? 14 divided by 2 equals 7, and 126 divided by 2 equals 63. Now the problem has become 63 divided by 7. If you remember the multiplication table, 63 divided by 7 equals 9. So you're probably wondering why this tip works. Let's look at it using a simpler division. 12 divided by 6 equals 2. And 6 divided by 3 also equals 2. And if you look closely, 6 and 3 is the result when you both divide 12 and 6 with 2. You'll get a new division, but the final quotient is totally unchanged. This tip also works if you multiply the dividend and the divisor by the same number as well. For example, 3,400 divided by 50 seems like a pretty complicated division. But if you double up both 3,400 and 50, you'll get 6,800 divided by 100. And since multiplying by 100 means the product will have 2 zeros at the end, dividing by 100 is taking 2 zeros away from the dividend. 6,800 divided by 100 equals 68. It might surprise you, but the result is the same if we divide 3,400 by 50. Pretty neat, right? Last but not least, we have tip number 5. Here's an example so you can understand it better. 312 divided by 24. If you don't like working with a multi-digit divisor like 24, you can break it down into smaller factors. Whoa, slow down there. I didn't mean break it literally. 24 is a result of 6 times 4. Instead of dividing 312 with the entire chunk of 24, you can divide it by 6 first, then take the quotient from the division and divide it by 4. Finally, after only 2 division steps, you have 312 divided by 24 equals 13. If you think dividing by 6, then 4 is still a challenge, you can always break it down into even smaller factors. 6 is 3 times 2, and 4 is 2 times 2. So you can take 312 and divide by these factors one by one until you run out of numbers. Good job! Now you know how to get to the multiplication and division answers easier. Let's quickly recap them. First, we learned how to multiply by numbers with zeros at the end. Second, we utilized the grid method to keep track of our multiplication. Third, we found out how to multiply by 9 and 11 quickly. Fourth, we can divide or multiply both the dividend and the divisor to make a new, easier division without affecting the quotient. And finally, we can break the divisor down into smaller factors, then take the dividend and divide by those smaller factors one by one. Remember to apply these tips whenever you can to speed up your math solving process. And if you feel like you need to top off your knowledge of multi-digit multiplication and long division, be sure to check out our previous lessons. Lastly, don't forget to practice multiplication and division every day until you get the hang of it. So stay tuned for our next video to learn all about it. Oh, and don't forget to subscribe to our channel and not miss out on any of our new content. See you next time!